Assalamu alaikum. Today we'll discuss about an important topic, multiplexer. This is an important topic in digital electronics. This word multiplexer comes from these two words, multiple plus switcher. Means this multiplexer works like a switch in many perspectives. Let's see what it does. It selects one signal from many, means there will be multiple signals and this device will select one signal from those, means it multiplexes the data. It is one kind of data selector as it selects data from many inputs. Marks many inputs, there will be many inputs and this will take the one inputs and give us one output, and this selection depends on the control signals. There will be some control signals. Depending upon those control signals, this device will give us one output, one single output. Let's see the definition of multiplexer. It is a combinational circuit. What is combinational circuit? Where the output depends on the current inputs, not on the previous input. That is combinational circuit. So it is a combinational circuit that has 2 to the power n input, means here total input will be 2 to the power n lines and a single output, means taking 2 to the power n inputs it will give us a single output. Here is the ratio will be 2 to the power n is to 1, means this is the input and this is our output. It works as an electronic switch that connects one of n input lines to an output lines, means there will be n line of inputs. Suppose there will be 3 line of inputs, n equals to 3, and we will got one output, and as it works like a switch, means if this line works or chooses and these two are in off condition, then this will be our output, or if this and this both are off, then this will be our output. This is how it acts like a switch. Let's see the block diagram of this multiplexer. Suppose this is a multiplexer and here will be input 2 to the power n is to 1, which is 2 to the power n input and 1 will be output. So here input lines will be 2 to the power n dot dot dot. Here will be 2 to the power n input lines and only one single output lines, and here will be n selector. Depending upon this n selector, one data will be selected from here and that will shown at the output. Let's see an example. Suppose this is a multiplexer of where the n equals to 2. So we have said that here will be n selector, means there will be 2 selector, and the combination of this selector means 2 to the power n, means 2 to the power 2. That means here will be 4 input lines and only one output lines. Let's see how it selects. We will denote these input lines as I0, I1, I2 and I3, and these two selector will be S1 and S0. We have said that there will be a number of selectors and depends or based upon these two selectors, here one inputs will be selected and then this will be shown in our outputs. Let's see how which combination can be done using these only 2 bits. So the combination will be 0 0 0 1 1 0 and 1 1. These 4 combination will be done using these 2 bits, and let's see how it works. Suppose if we select this 0 0 as our selector inputs, then from this I0 will be selected and there will be shown our I0 output. Then if we select this 0 1 as selector, then this I1 will be selected and this will be shown in our output. Similarly, if we select this 1 1 as our selector input, then this I3 will be selected and this will be shown in our output. This is how our multiplexer works. Of your TV remote, you have many channels as inputs, but this remote works as a selector, means it selects that you chose one channel and it shows on the TV screen. This is how our marks works. Another important thing is it is functionally complete, means all the Boolean function can be realized using one multiplexer without any other gates, means it don't need any other gates to implement any Boolean function. As in the decoder we have said that if there will be sum of products in our output, then we will have to add a OR gate to show our output, but here will be we don't use any other gates. We will just use one multiplexer. Here we have said that here will be n selector, and the combination of n selector means 2 to the power n will be our input lines. But it is a matter of confusion that the function that given to us, or the total variable like a, B, C, or X, Y, Z, etc., etc. In other electrical circuit, we denoted this as our n input lines, but here this can't be. Here this will be considered as n plus 1, means total input variables will be n plus 1, and we will suppose here n plus 1 equals to 3, A, B, C, 3, and so n equals to 2, means the selector will be 2, but we have 3 variables. We will use 2 as selectors and 1 as our input combination lines. Let's see this with an example. Here we have a question that implement this function using mux. There is given a function f of a, b, c, d, means 4 total variables, and we will got the output as minterms 0, 1, 3, 4, 8, 9, 15. What does this function means? This means that this f is 1 for the minterms 0, 1, 3, 4, 8, 9, 15, and it will be 0 for in other minterms. Therefore, only these minterms we will got this function as 1. As here total input is 4, so their total combination will be 2 to the power 4, means 16. So here total combination will be, we have already said that this will be considered as n plus 1, means here n plus 1 will be 4. So the n will be 3, means here selector will be 3. And another one will be works as input lines combination. Here we have select B, C, and D as our selector, and we will see the combination of A as our input lines combination. As here we have said that total combination can be done as 16. So we have written here 16 codes in our table, and this combination can be this in these forms: I0, I1, I2, I3, I4, I7. And this a prime will be 0 and this 1. For this a prime equals to 0, the minterms will be 0 to 7. And for the a equals to 1, the minterms will be considered as 8 to 15. So here the combination will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Let's which minterms are given in our questions. We only need those minterms. Let's indicate that. Here is 0, then 1, then 3, then 4, 8, 9, and 15. Those minterms are needed for the output of this required function. As here our input line n equals to 2, so we have already said that the inputs of our multiplexer will be 2 to the power n. So here it is 2 to the power 3, means 8. We will have 8 input lines in our multiplexers. Let's see which input lines are given to as input. Here for both A and A0 are selected for our input lines. So here the total ultimate function will be 1. Here also we need the both, so here will be also 1. And here we don't have any output for our required function, so here we'll write as 0. Then here just we need 3. 3 is in the line of A prime, so we will use A prime. Then here for also we'll use A prime. Here no function for our output function, so 0, 0. And here is 15, which we need as our outputs, and this is in the line of A. So here our input combination indicated as A. Let's draw the circuit. This is our mux circuit. Here the selector will be N, which we have considered as B, C, and D as our selector. We'll got one output F, so the combination of here will be 2 to the power N, which is 8. So this mask is 8, 1 mask. And this ultimate input will be I0, I1, I2, I3, I4, I5, I6, and I7. Let's see which inputs will be given in these 8 lines of inputs. For this we have drawn our short table. Here A will be used to decide which group of inputs, upper or lower 8 inputs, is selected. We have said that there will be 2 lines of 8 inputs. So A is used to consider to select which input will be selected for our circuit. A and A prime are used to enable groups of I inputs. Inputs I0 to I7 are defined using A and A0 based on which minterms make of F equals to 1. These inputs are then fed into the mux to get our output F. From this we can see that the I for I0 and I1 input, we got the function of A as 1 and 1. So here the input of I0 and I1 will be 1. This one will be go as input of I0 and I1. Then C for I2 we got as 0. So here we will give the I0 as 0 input, and for I3 and I4 we have A prime. So for I3 and I4 we will give as A prime of our input lines. Then for I5 and I6 we got 0, and I7 we got A. So for I7 we got A, and I5 and I6 we got 0, and 0 we have already lined, so we will turn this line lower and connect with this. This is our ultimate mux function circuit. Here the inputs I0 to I7 are defined using A and A prime based on which terms makes F equals to 1. As here the total input lines are less than from our total input variables, so we have to draw this table to select which input will be gone through our circuit. This is how you can solve a mux circuit problem. We see this, then this will be more clear to us. We have said that here will be 8 lines for A equals to 0 and another 8 lines where A equals to 1. Let's see how it works. We have considered A equals to 0 and took first 8 inputs when the A equals to 0. So we have written A equals to 0, and let's write the combination of our 3 selector B, C, D. These are 0, 0, 0, 0, 1, 0, 1, 0, 1, 0. This is how we write all the combination, and this is denoted as I0 to I7. For this we know that this represent minterms as 0, this represent 1, this represent 2, this represent 3 in our decimal boolean function. And according to our given function, here the minterms that are given is 0, 1, 3, 4, 8, 9, 15. So we will write the function as 1 at those minterms. So here is 0. So in the minterm of 0 we will write 1. In the minterm of 1 we will write also 1. And here there is no minterm 2, so in the minterm 2 we will write the function as 0. This is how we will write all the function. And similarly for A equals to 1, we will also write another 8 function which represent the minterms from 8 to 15. For this we will write A as 1, 1, 1, and we will then again write the combination of B, C, D 0, 0, 0 to 1, 1, 1. And similarly we will write the minterms that are given on our question. The function will be 1 or otherwise the function will give us 0. This is how we can write this table, and according to this table the circuit will be done.